Okay. Today we want to look at one of the gas laws, the Charles law, because the last time we looked at Boyle's law. Boyle's law tells the relationship between volume and pressure when the temperature is constant. But today let's look at Charles law, because Charles law is also an important part of the gas law, which states that as constant pressure, the volume of a fixed mass of gas is directly proportional to the temperature, absolute temperature. You can also state it that the Charles law states that at constant pressure, or when the pressure is constant, the volume of a given mass of gas is directly proportional to the temperature. So here we'll be mentioning volume. I'm looking at temperature, but no pressure is mentioned. So pressure in this context is constant. It's not part of the question. So if you are solving a jam pass question or a waec question or Charles law, so even if you don't know the topic, at least through your parameters, you'll be able to figure it out that okay, this is Boyle's law and this is Charles law. So, and that is that. And let us look at in the simple words, when volume is directly proportional to the temperature, it means that when temperature increases, the volume also increases, or when volume increases, the temperature also increases. So and when temperature decreases, the volume also decreases. So but pressure is not mentioned here. Pressure is constant. And so for calculation, we have some important rules here. Unlike Boyle's law, when probably we are not just converting anything, temperature is usually given in Kelvin. So, and you have to use Kelvin to calculate the Charles law. Like everyday example, like when a balloon expands under the sun, and it shrinks when it's cool. So all these things are concepts of Charles law. So what happens is that we are going to be looking at Charles law. V is directly proportional to temperature. So we have V1 over T1 equals to what? V2 over T2. Now for the sake of calculations, let's look at this. Work example. A gas occupies 300 cm3 at 27 degrees Celsius. Find a volume at 127 degrees Celsius when pressure is constant. Now it shows that this kind of question, a lot of information was given. Now they said a gas law occupies 300 centimeter cube. That is what your V1, that's the first volume. Then your temperature here is what, 27 degrees. The V2 is what we are looking for, and second temperature. Then mind you must convert the temperature in degrees Celsius to Kelvin. Like this one now, the V1, the T1 was given to you as 27, so you have to plus 273 to that. That is what? 2. So if it's plus 27 to that 300K, if you have to apply the Charles law, now look at, so let's apply the Charles law. So from the information from this question, you see 300 cm3 is the V1, then that's the V1. Then your T1 is what, 27 degrees Celsius converted to Kelvin. Then you have this. We are looking for V2. Then the second temperature in the question after the second volume is 127. Then you plus it plus 273K. Then it gives you what? So our V2 is what, unknown. Our V1 is 300 centimeter. Our T1 is what, 300K. Our T2 is 400K. So if you have V1 over T1 equals to V2 over T2, that's 300 over 300 equals to V2 over 4. So that's 300 times 400 over 300. And you have your answer as what? 400 cm3. Second volume. Volume 2, that is how the 400 cm3 is gotten. So in the comment section, I'm going to show some mathematical expressions there. So that is that. Now let's look at another example. They said a gas has a volume of 500 cm3 at 27 degrees. What will be the volume at minus this? Now look at this. The first thing here is you have the first volume, which is 500 cm3 at 27. So the 27 is the first temperature which we are going to convert. Then after converting it is 27 plus 273. Then you calculate, you have your answer. When you apply the formula V1 over T1 equals to V2 over T2, you arrive at this answer. So you can check the thorough calculations on that in the comment box. I'm going to put it inside the comment box so you see it. And now the other question is, look at the questions are so simple in the sense that you will see it in that aspect, in that area. of a gas occupies 400 cm cube at 17 degrees. Then calculate the volume at 77. So V1 in that question is 400 cm cube. T1 is 17 plus 273. That then your V2 is what? Unknown, while 77 plus 273 is so we have V1 over T1 equals to what? V2 over T2. So that is all about Charle's law. So Charle's law is not something difficult. Just find your parameters, look at your V1, identify your V1, write your figure, your T1. If it is given to you in Kelvin, you don't need to convert. But if it is given to you in degrees Celsius, then you convert it. Then look for your V2. If you look for your V2, then you must be given the T2. So that is that. And mind you, it's not only volume you are looking for. Sometimes they give you volume 1, volume 2, and they give you temperature 1, look for temperature 2. Your final answer for that one is going to be in Kelvin. So don't make mistake of that. That is Charle's law. So Charle's law is a law that tells us that when the pressure is constant, volume is directly proportional to the temperature. When volume increases, temperature increases, and when volume decreases, temperature decreases. So that is that. There are so many other questions. I'm going to put the questions and their workings and answer in the first comment of the comment box. So that is that. We see you in our next video, or still under the gas law. I want to finish all the series at once so we can see all the questions here. And that is that. Don't forget the important rules in solving them, and don't forget the definition of the Charle's law. So that is that. Don't forget to subscribe. Then see you in our next video.